Hi, in this video we're going to look at the idea of the notion of gradient. In its very simplest terms, gradient is simply the slope of a line. Now, there are different ways in which we could try and define this. We could say that this line AB is sloping up to the right or sloping down to the left. Now, those would both be adequate descriptions of what's happening with that line, but they're both rather vague. So we want to have something that's a little bit more quantitative. So maybe I could say, well, to get from A to B, I've gone across a certain way and then I've gone up a certain amount. Or another person might have said, no, to get from A to B, I've gone up a certain amount and then I've gone across a certain amount. So the first person might say, okay, to get from A to B, I've moved across 5 places and I've gone up 2 places. But the other person might say, no, hang on, I think you've gone up 2 places and across 5 places. I think you'll agree both of them are correct statements. But we needed to have one unique way of being able to describe the slope, and we needed to decide, was it going to be how much I go up and how much I go across, or was it going to be how much I go across and how much I go up? And mathematicians decided, and they came up with this. Quite simply, gradient was going to be rise over run. Rise, how much I've gone across, up rather, and run, how much I've gone across. So in this case, I can see that I've risen by 2 and I've run by 5. And so this fraction over here is going to describe the gradient, the slope of this line. It's a rise of 2 and a run of 5. Here we have a slightly different line, the line C to D. So what's the gradient of this line? Well, we can see that it's got a much steeper slope than the line A to B. If we look at the rise, how much it's gone up, well, it's gone up 5 and it's gone across 2. So my gradient in this situation, the rise over run, well, in this case is going to be a rise of 5 and a run of 2. And that's the gradient for this line. Remember, we always have to define gradient as rise over run. And here I've got a third line segment, the line going from F to E. What's that gradient going to be? Well, I can see that the rise part is going to be a rise of 3, and the run part, how much I go across, that's a run of 4. So gradient, in this case, the rise over the run, is going to include the numbers 3 and 4. Now, we do need to notice something quite significant here. These first 2 lines that we had were lines that were sloping from the bottom left to the top right. Whereas this one does the opposite. It goes from the bottom right to the top left. And we need to have some way of being able to distinguish between these two. And we can. We say when lines are going from bottom left to top right, going in that direction there, then they're going to be positive numbers. They're going to be positive gradients. However, when a line is going, oopsie, what's happened there? When a line is going the other way, when it's going this way, then we're going to say it's going to be a negative gradient. So we're going to say this one is going to be minus 3 over 4. So 2 really important things there. Gradient is always rise over run. If the line goes like this, then we say it's positive. If the line goes like that, then we say it's going to be negative. We still work with the same rise over run concept, but we're going to have one positive or one negative, depending upon which way it slopes. So let's look at some examples here. We've got 4 points on the Cartesian plane, and we can look to try and get the gradient of the lines that would join these points together. Now, for some reason known only to mathematicians in the past, we go and abbreviate gradient. Instead of writing the word gradient, we tend to use the letter M for gradient. So let's see if we wanted to work out the gradient of the line from G to H. So we'll work out that gradient there like that. Well, I say G with a underscore, M with an underscore GH is going to be rise over run. So my rise is a rise of 2. The run going across there is a run of 1, 2, 3, 4. So it's going to be 2 over 4, which simplifies to 1 over 2. If I want to find the gradient of HB, so in other words, I want to find the gradient between these 2 points here, I need to figure out what is the rise. The rise is a rise of 2. The run, the distance across there, that's a distance of 3. But we do need to notice that this line is not going up to the right, to the left-hand side. Yeah, let's try that again. It's not going up to the right-hand side, it's going up to the left-hand side. And so this has a negative gradient. So I'm going to put a minus in front of it. Just rub these out so they don't get in the way. Let's look at another gradient. This time it's the gradient of the line GA. I want to figure out what's happening with this gradient here. So the line GA, it's this one that's coming all the way, whoopsie, across like that, to G to A. Not very accurate. Let's see if we can draw a little bit better in freehand. There we go. GA, what is that gradient going to be? Well, how much have I risen by? I've risen that amount there. I've gone up 1, 2, 3, 4 blocks. So it's a rise of 4. And I've gone across my run. This has been a run of 1, 2, 3, 4, 5, 6. And once again, it's a negative rise over run, so it's going to be negative 4 over 6. And because we're good mathematicians, we don't leave that fraction unsimplified. We're going to write this as minus 2 over 3. Hang on, I hear you say. Minus 2 over 3, minus 2 over 3. So those two lines, the lines GA and the line HB, have the same gradient. In other words, we can say that HB is parallel to GA. And that's quite a useful way of being able to prove that lines are parallel. If you can figure out their gradients and show that their gradients are the same, then we can do that. Now, it'd be good if we had a formula that would help us get this gradient without having to figure out is it positive or negative gradients, things like that. And there is a way in which we can do this. So let's have a look at this. If we go and highlight these points over here, this is the point 8 minus 2. Point G, I'm going to rub these lines out over here because I don't actually want them for the time being. Let's just cause a bit of confusion. G is the point 2, 2. And then I'm going to put a third point in over here. I'm going to put the coordinates of this point here. The coordinate of that point is 2 and minus 2. Now, if I want to figure out how much I have risen by, so in other words, how much I've gone up there, well, then I need to look at my y values because my rise is how much my y values have gone up. And that is a gap of 4, we agreed. How do I get 4? Well, I'm saying actually 2 minus 2. That would give me the gap of 4. If I want to figure out the distance that's going across over here, well, then it's basically looking at the differences between the x values. So the difference between 2 and 8, well, that's minus 6. So I've got over here 2 minus 8. And that gives me my number 4 over minus 6, or minus 4 over 6. It comes to the same thing. And there we have our gradient. Now, the formula for that looks something like this. I need to have 2 points. I'm going to call the first point x1, y1, and I'm going to call the second point x2, y2. And now, in order to work out my gradient, I'm going to say my rise is going to be determined or worked out by saying y2 minus y1, and then my run is going to be determined by taking the same points coordinates that I started with on the top, x2 minus x1. So I start with y2 up the top, so y2 minus y1, then I must say x2 minus x1. Or I could have written it like this. I could say m is going to be y1 minus y2 divided by x1 minus x2. It doesn't really matter which way around you put it, as long as you have the y's up at the top, the x's at the bottom, and the point that you start with must be the first coordinates on top and bottom line. So does that work for this example that we had over here, the gradient of GA? Well, if I said that 2, 2 was the point x1, y1, and I said the point 8 minus 2 was the point x2, y2, well, then my gradient's going to be y2 minus y1. That's minus 2 minus 2 over x2, which is 8, minus x1, which is 2. That's going to give me my minus 4 over 6, which we said was minus 2/3. Had I gone about it the other way around, had I gone and said, had I started, instead of starting with the point x2, y2, if I'd started with the point x1, y1, then I'd have said 2 minus minus 2 over 2 minus 8. Now I come up with a positive 4 on the top, but I come up with a negative 6 on the bottom, so I still end up with that negative fraction of 2/3. It works both ways. And that basically is how we go about getting the gradient of a line.